Welcome back, iPad Initiative students. We're doing part 2 of section 2.3, which is the law of deduction here. We're talking about the second law of logic, which is the law of syllogism. And the law of syllogism, if you remember the transitive property from algebra, it reminds me a lot of the transitive property. The transitive property says, if A equals B and B equals C, then A would have to equal C. So it's going from A to B, B equals C, then we conclude from the beginning to the end. That's exactly like the law of syllogism will work here. It says, if we have the hypothesis P, which would imply Q, then if we're given Q implies R, then we can skip from our first hypothesis to our last conclusion, R. So if we're given P, then we could conclude R. If both of these are true, then this statement will always be true. Let's see if we have an example over here on this. So it says determine if the conjecture is valid by the law of syllogism. So let's give the first example says given a figure is a kite. So our first hypothesis here is a figure is a kite. We'll call that P. Then it is a quadrilateral. This would have to be our Q right here. Now we should be, if it's following the law of syllogism, this hypothesis should be the Q, which is it's a quadrilateral, which it is. Then we should have a new conclusion, which would be our R. So it is a polygon would be our R. So down here in the conjecture, we should have P, which would imply R to follow the law of syllogism. So let's see, a figure is a kite. That's what we have for our P. Then it is a polygon, which is what we have for our R. So therefore, this would be a valid use of the law of syllogism. It would be a valid argument. So P implies Q, Q implies R, so P would have to imply R. Let's see if we have another valid one right down here. Alright, so it starts off again with the first hypothesis is a number divisible by 2, that would be our P. It is even would have to be our Q. Notice that this better be our Q, and it is here, to imply something new, which is it is an integer, would be our R. So remember the law of syllogism starts us back with P. So let's see, a number is an integer. Oops, well our P is a number is divisible by 2. So we can't, if we're given R here and not P, then really we cannot conclude whatever the conclusion is here, which happens to be what? P. So this would be an invalid argument. We would have to have P here to imply R here for it to be the law of syllogism. So that one would be invalid. Alright, regular class at this time would be doing 6 and 7 from page 91. iPad students, yours will be a different assignment. Let's see, draw a conclusion from the given information. So let's see here. If 2y equals 4, then z equals negative 1. Then we got if x plus 3 equals 12, then 2y equals 4. And then it looks like we're given x plus 3 equals 12 here, and we're supposed to conclude something from this. Alright, so we need to try and piece together one of those laws to try and give us a conclusion. What I'm noticing is we've got two things that are the same here and here. So we want to try and probably place those back to back. Well, to do that, to make one of them our conclusion and then follow it by our hypothesis, we would have to put this statement first. So I'm going to say if x plus 3 equals 12, then 2y equals 4. So this part right here, I'm going to call that our P. I'm going to call this 2y equals 4 our Q. So now if I write that second one down, I'll have f2y equals 4, then z equals -1. Well, it looks like we have our Q again here, and then a new state or new conclusion here, which would be our R. So if I have this lined up like this, I can conclude that if I have P, then R must be true. Well, this x plus 3 equals 12, that is our P again. So what can I conclude would have to be my R, which is z equals -1. So sometimes to make a valid point, which is the law of syllogism, to make it a valid argument, we might have to rearrange the statements to put it in the order that makes sense for that law. Let's see what we have down here. It says, if the sum of the measures of two angles is 180 degrees, then the angles are supplementary. Well, yeah, we've studied that. If two angles are supplementary, then they are not angles of a triangle. Well, that's true because the angles of a triangle add up to equal 180. If two of the angles take 180 degrees, there's no measurement left for that third angle. So it says the measure of angle A equals 35 degrees and the measure of angle B equals 45 degrees. So I guess we probably want to see if those two add up to give us the 180, which they do. So those would be supplementary angles. Well, if they're supplementary angles, then we can conclude that the measure or angle A and angle B are not angles of a triangle. So that would be the logical argument that we could draw from that information. Alright, the regular class would be doing 8 and 14 from page 91. There would be the up one, down ones that we would play. I think here's a recap of the two laws. iPad class, we are incorporating boxes now. So if you've got your assignments done for the week, we will do boxes. And that looks like it's going to conclude section 2-3 for the Geometry iPad Initiative class. Mr. Lane signing off from OHS. Have a good day.